Ninja Warriors, welcome to yet another power packed session. So you guys were waiting for the roar series vector session. So vector session we are going to discuss today. Today only all the concepts will be discussed today. All the questions, all the PYQs, and on top of that I'll be telling you that what is exactly the weightage of vectors chapter is in your upcoming JEE main. Okay. All right, before I start, do let me know whether I am perfectly audible and visible so that we can proceed. And obviously, you have to like the session and share this session with your fellow JE aspirant. Am I audible? Just confirm one thing. Good evening, Vishnu. Good evening, Sadia. Hi, Moon. Hi, Magnus. How are you all? All good? Good evening. Good evening. Keep liking, keep joining, keep liking the session. Yes. Okay, so I believe I'm audible. Okay, I guess I am audible. I'm perfectly audible, right? So, vectors chapter. Okay, so you all know that vectors and 3D geometry is a high weighted chapter, right? You can expect 3 questions from vectors and 3D geometry. That means 12 marks. Sometimes you can expect 4 questions alone from vectors and 3D geometry, right? So 3 questions so you can expect from vector and 3D geometry, high weighted chapter. And yeah, so let's get started. This is my first live class, ma'am. I have watched your past video. What an amazing thing. Okay, so welcome to the live session. Good evening, Darshan. Good evening. Keep joining. Do like the session, okay? Are you guys liking the session? Have you liked the session? Yes? Okay. All right. Let me just share this session on Telegram also because some students complain that, ma'am, we didn't know that today was live session and we got late and yeah. So let me just give me a moment. Let me just share this. Okay. All right, because this is gonna be a very important session, right? So, yes, here we go. Let me share, and here we are. Okay, I believe you all are connected on Telegram, right? You guys are connected over Telegram, yes? Yes, Sunil Kumar, what are you saying? No, 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 it's not physics, it's mathematics, right? Okay, so are we ready? This will not include 3D geometry. So 3D geometry, we will study a separate session. So this is only gonna be vectors, okay? So say about declaration, please. I guess you are talking about your application form, right? So I believe that wait for two category student, wait for 2 3 days. We all believe that in 2 3 days we can expect some clarification over the category certificate, whether it is mandatory or it is fine if we upload a declaration certificate. Okay, so this session is going to go about 2 to 3 hours, right? 3 hours mostly. Okay, all right. Chalo, let's start. Are we ready? All right. So, for all of those who are coming for the very first time to this channel, this is my brief introduction. My name is Namrata, and I have over more than 10 years of teaching experience in both online and offline. These are my credentials. Okay. All right. Yes. Yes, Majumita. Hi, Havish. How are you? All right. So, we are starting now. Okay. We are starting. Now, physical quantities. What are physical quantities? So physical quantities are of 2 types. First is scalar quantity, and second one will be vector quantity. Scalar quantity, vector quantity. Okay, all right. Now scalar quantity will be having own magnitude. Okay. For example, if I give you the example, for example, distance. If I ask you how much far your place is from my place, so you will only tell me unit Like, ma'am, 2 kilometers, 3 kilometers. I have not asked you in which direction. So distance is only about the number, the magnitude, okay? So distance is only about magnitude, distance. This is your distance, or you can call it speed as well. Speed is also a scalar quantity because speed is associated with how far you are going. Okay, ma'am, 3 meter per second. So basically, again, a number is involved. Magnitude is involved. There is no direction. But vector quantity, on the other hand, will have what? Magnitude. It will definitely have magnitude plus direction, both. Magnitude as well as direction. Okay. All right. Clear? All right. For example, displacement. For example, displacement. So displacement is actually a vector version of distance. Okay, so we have a similarity between distance and displacement. It's just that the displacement is having magnitude as well as direction both. Okay, now direction, magnitude as well as direction. And another example, velocity. Yes, again, velocity. So you might have studied this in your previous like physics session also, basics of vector. Velocity again is again the vector version of speed. Okay, so velocity is definitely having magnitude 3 meter per second, but in what direction is what you have to give. Okay, all right. So I guess scalar quantity, vector quantity, the difference is pretty clear to us. But now let us understand whether scalar and vector or not. So I have a few questions for you. What do you think? What about force? Is force a vector quantity? Tell me. Is force a vector quantity? Okay. So suppose, let us understand. Suppose I have this block, okay, and of block of some weight, okay, mass m. Now I am applying a force of ton. 2 Newton is my force. Okay, I'm applying a force of 2 Newton. You must be thinking, ma'am, suddenly physics class you started. Okay, so force is 2 Newton, right? So now the problem is, so what will happen to this box? So if I apply this force in this direction, then the block will probably move. If I apply the force in this direction, if you are applying a force, and so basically what is happening, the direction in which the force is getting applied is mattering. Direction matters. So that's why force is a vector quantity. Force is a vector quantity. Are you getting my point? Yes, understanding everything. Yes, you guys always ask how many hours, how many hours. So we'll try to wrap up this session before 8 p.m. Okay. So before 8 p.m. before your dinner time, guys. Okay. All right. Chalo. Now, is angle a vector quantity? How many of you say angle is a vector quantity? Okay. It's because for all of those who have studied trigonometry from me, that angle is actually, angle has some direction sense, right? Audio is breaking, you guys are saying. Okay, let me. Happy Diwali, Kritik. Audio is breaking, you guys are saying. Okay. Hold on, let me check. Let me change some audio settings. Okay. No, here for me, audio is good. Hold on. I believe that let me check some sound settings. Okay, hardware and sounds. Everything should be disabled. Jack mic should be enabled. Disable, disable, disable. This should also be disable. Okay. Okay. All right. Yes, yes, yes. I believe that now the breaking of sound will not happen. Okay. So is angle a vector quantity? How many of you tell me? How many of you say angle is a vector quantity? Tell me, tell me. Yes, Vishnu, I guess that I have fixed it. Now you tell me if voice breaks, okay? Is angle a vector quantity? So let us check, let us understand that, ma'am, you told us that if an angle is clockwise, so clockwise angle is positive and anti-clockwise angle is negative. That means angle is having direction, ma'am. Angle is having magnitude. Angle is having direction. So it must be a vector quantity. But no, hell no. This is not at all a vector quantity. This is not at all a vector quantity. Okay. Not at all a vector quantity. Cool? Yes. This is a scalar quantity, not a vector quantity. This is a scalar quantity. Scalar quantity. Why, ma'am? This is having magnitude, this is having direction. Why are you calling it as a scalar quantity and not vector quantity? See, one thing which some people only tell you that vector quantity, they will tell you, ma'am, magnitude plus direction. But there is one more thing. What is that one more thing? One more thing is that it should obey vector laws. It should obey vector's law of algebra. What is vector law of algebra? So basically, in angle, what do we do? See, now I will tell you. In force, what do you do? If I say F1 is 2 Newton, F2 is 1 Newton, okay? And I am applying this force in which direction? Tell me. Force F1 is in this direction, F2 is in this direction. So tell me, F1 plus F2 will be what? So F1 plus F2 will be 2 plus 1. Ma'am, no. 3 Newton, nahi. Sorry, 2 minus 1 Newton. So what did we do? Did we add it just like mathematics, 2 plus 1? We don't do that. What did we do? We applied vector law. Vector law of addition. It says that you have to allow it with sign. But in angle, what happens then, ma'am? In angle, if I tell you theta 1 is 60 degree, just tell me theta 1 plus theta 2 will give you what? 60 plus 30, that is 90 degrees. So it is following normal laws of mathematics. It is not following vector law. That is why this is not a vector quantity. Okay. Now vectors. Now let us understand vectors. Okay. What is a vector? Vector is a directed line segment. Directed line segment. Are you guys making notes as well? A directed line segment is called as a vector. Short and sweet definition of vector. Directed line segment. Hold on. So a vector will have a tail. Can you see the tail of the vector? And vector will have a final point. Okay, this is a tail and this is a final point of the vector. Final point. So basically this tail, I can call it as A and final point is B, and I will denote it as a AB vector, a directed line segments. Okay. Now the length of the line segment, will be what? Segment will be magnitude of this vector, right? To determine any vector, you just tell me. You determine any vector, what exactly do you need? You need magnitude, you need direction. So now direction, magnitude. So magnitude of a vector will be what? Length. This length of AB, length of line segment AB will be this. Okay. All right. That is one thing. And yes. So length is this. That's it. Okay. So this is what you call it as a vector quantity. All right. Okay. Now let us understand the types of vectors. First type is zero vector or all or null vector. So a zero vector is such a vector whose magnitude is zero. And what about direction? Who can tell me about the? Tell me. Okay, I'll give you two options. I will give you two options, okay, for this. First one is no direction. Second one is any direction. Can anyone tell me what is the correct direction for a null vector? Yeah, PYQs covered, do not worry. Tell me. So, no direction is a wrong approach. See, if you are calling it as a vector, zero vector or null vector, that means it is a vector. Are you agreeing on it? Yes, ma'am, it is a vector, okay? So, magnitude 0, agree. But no direction, if anything which is having no direction, that is in the first place will not be a vector, right? So, that means it will be having any direction. Think about it. It will be having any direction. How do you represent a null vector? So it's just that it starts here and ends here. It's like that. Okay. All right. Clear. So any direction. Now unit vector. Okay. Let us understand what is a unit vector. So a vector which is having a magnitude 1 is called as a unit vector. Okay. How do we denote a unit vector? Unit vector is denoted by a cap. Any vector which is having cap on the top, it will become a unit vector. Okay. So if any vector A vector is given to you, and you have to figure out the direction of A vector. So that will be A cap, that will be equals to A vector upon magnitude of A vector. A cap will be A vector upon magnitude of the A vector. This is the formula. How do you calculate unit vector? This is very, very important. Okay. All right, ma'am. Got it. Now, unit vector in the direction of x-axis. Can anybody tell me? Unit vector in the direction of x-axis. Hold on. So, ma'am, this is your x-axis. Okay. X-axis. This is your y-axis. This is your z-axis. So, unit vector in the direction of x-axis will be just this vector. Okay. And this will be having magnitude 1 and direction will be towards the positive x-axis. So, this is going to become I cap. So, this is I cap. Okay. I cap. Unit vector in the direction of y-axis. So, j cap. Cap means magnitude 1 automatically. Nobody has to mention. And this is going to be k cap. So, this is how we denote these three important vectors I, j and k. Okay. All right. I, j and k. Clear? Perfect. Now, again, a few more questions I would like to ask. Unit vector. Okay. So, number of unit vectors perpendicular to a given plane in space is 2. So, tell me it is true or false. Both the statements, statement number 1, statement number 2. What do you think? Let us understand, number of unit vectors perpendicular to a given plane. Okay. So, a plane is given to you. So, basically, this is your mobile. This is my mobile phone, right? And there is this plane. Now, I want the number of unit vectors perpendicular to a given plane. Okay. So, are they 2 or is that 1 or is that infinite? Just tell me. 1, 2 or infinite? So, The correct answer is 2. Okay, this is absolutely true. So if a plane is given to you, you have to figure out two vectors which are perpendicular to this plane. So one unit vector that means magnitude is fixed. Okay, one unit vector will be towards you guys. One unit vector will be towards you, and another unit vector will be towards me, towards this. Okay, so there will be this direction and this direction, so there will be two vectors. So suppose if I want to draw and let you know, okay, that okay, this is a plane, this is your plane. Okay, so this is your plane, one vector will be this vector, another will be this vector. Again, this is perpendicular to the plane. Getting it? So yes, this is true absolutely. What about the second point? What about the second point? Number of unit vectors perpendicular to a given line in space is infinite. Okay, hold on. Number of unit vector perpendicular to a given line. Okay, so suppose I am having a line. This is my line. Let us try to draw perpendicular vector. So this is perpendicular to this line. Yes, ma'am. And one vector which is perpendicular to this line. Yes, ma'am. So there will be so many, like so many perpendicular vectors. Can you see so many perpendicular vectors? So many perpendicular vectors. Okay. Hold on. Let me tell you. Suppose this is your line. Okay. So this, my finger will represent perpendicular unit vectors. Okay. So this is like going up. Is it perpendicular? Yes, ma'am. Now, if I just change the direction of this, understand. Is this a unit vector still perpendicular? Yes, ma'am. Every time it is perpendicular. So see, this direction, this direction, this direction. How many? Infinite. Are you able to imagine? Are you able to imagine? There is this line. This upward facing vector is also perpendicular. This is also perpendicular. This is. So that means basically a circle is getting formed. A circle is getting formed. Circle of perpendicular vector. So that is why it is infinite. Absolutely true. Okay. So this thing is true. Perfect. Okay. Clear. All right. Now, let us understand the difference between mathematical vectors and physical vectors. That means Shreyas sir's vectors and Ninja ma'am's vector. Okay. So in mathematics, okay, free vectors are something that, suppose I am having this vector, right? Suppose I am having this vector. Now, what I can do is, without changing magnitude and direction, I can just shift this vector in such a way that it will become this. Both are same only. All the vectors you are seeing on the screen are having same direction. Yes or no? Yes, ma'am. Direction is same. Magnitude is also same. So this is the free vector. Like you, what you can do is, if this is the vector pointing in this direction, so you can just move this vector. You cannot rotate it. You cannot just rotate it, but you can keep the direction fixed in this direction, and you can just move it without changing the basically without changing anything. Okay. All right. Yes. Perfect. Okay. So a vector that maintains the same magnitude and direction regardless of its position. So in mathematics, we'll talk about this only. But what about localized or fixed vectors? So in physics, especially in physics, you will only study fixed vector. Why, ma'am? Why is it happening? See, why I'm telling you this. Suppose there is a mass, block of mass m, right? And you are applying a force, okay? So force is equals to 2 Newton. And now if you want this to become a free vector, that means now you will move this. You will move this, okay? So now force will be applicable over here, and you will see that, okay, the impact of this force should be same. But it is not possible in physics, right? So if the point of the whole scenario gets disturbed. That's why in physics, you will have fixed vectors, and in maths, you will have free vectors. Are you getting my point? Got it? Yes. All right. Now, another type is collinear vectors or parallel vectors. Collinear and parallel. Okay. So, two or more vectors are collinear if their directed line segments are parallel. Okay. Disregard with their magnitude. So, basically, these two vectors, they are different in magnitude. But can you see these two are parallel vectors? So, parallel means collinear. Parallel, and we call it as like vectors also. So like vectors, okay. And if two vectors are anti-parallel, can you see that even though they are parallel, we cannot call it as parallel, they are anti-parallel. So anti-parallel, and again the voice is breaking, you guys are complaining. Unlike vectors, unlike vectors, okay. All right. So the angle between these two vectors will be, in between parallel vectors will be 0 degree. Angle between vectors, or by the way, these two, both of them makes collinear only. So these two are collinear only. Okay. Theta is 180 degree in case of anti-parallel vectors. Okay. So this is having same direction, obviously same direction. And this will have opposite direction. Opposite direction. Good evening, Aditya. Good evening. Good evening. Okay. Let me check one more time. Okay. Connected. Disabled. Microphone is disabled. Microphone array disabled. Jack mic is ticked. Disconnected. Device. Why is it breaking? I don't know. Okay. Now this is very important. Relation between two parallel vectors. Relation between two parallel vectors. Ma'am, I think this is your mic wire problem, ma'am. I don't think so. This is my mic wire problem. No. I have two mics, but both the mics are giving me same problem. Okay. So relation between two parallel vectors. Now this is very important. Suppose A and B are two parallel vectors, or A and B are two anti-parallel vectors basically. Okay. So what do we write? In both the cases, A is equals to lambda times B vector. In this case, lambda will be greater than 0. And this is also A is equals to lambda times B. In this case, lambda will be less than 0 because both are having opposite sign. Okay. Very, very important. Okay. All right. Yes, this is one shot. This is one shot. Okay. All right. Okay. Now relation between two parallel vectors, I already told you that if A and B are two non-zero, non-parallel vectors, if they are two non-zero vectors, and if they are non-parallel, understand if what will happen if they are non-parallel. Okay. So if you write again, see this is the same thing. Lambda A plus mu B equals to 0, or you can just skip this actually. Actually, we can just skip this. Yes. Let's not get confused. Yes, relation between parallel vectors here. Okay. And if your A is not parallel to B, not parallel to B, A is not parallel to B, then what will happen? A vector, B vector. Then if you write A is equals to lambda B, then lambda should come out as 0. That means this is like indicating you, mathematics is telling you, bhai, bro, this is not parallel vectors. Okay. All right. Clear? Chalo. Now let us do one question. Let's start with one question. Okay. Yes, you can continue from here. Don't worry. The value of lambda. when A and B are parallel vectors? Tell me, tell me. The value of lambda when A and B are parallel vectors. Solve it, guys, solve it. Okay, so we know that A is equals to mu B. This time, because lambda they have used, no? So what I will be writing is A is equals to mu times B. So what is A? A vector is 2I cap minus 3J cap plus K cap. This is equals to mu times 8I cap plus lambda J cap plus 4K cap. Okay, you guys are faster. You guys are faster than me. Huh? So what are you doing? Basically, you don't have to do it, right? So you understand this is your 2, 8 mu. 2 is equals to 8 mu. First thing. Second, minus 3 is equals to lambda mu. This is second thing. And third is 1 is equals to 4 mu. Basically, what you have done over here is you have compared the components I cap, J cap, K cap components. Okay. So here the mu will become what? Mu will be 1 by 4. And if you put mu over here, your lambda will be there. So this is lambda 1 by 4. Lambda will be equals to minus 12. So minus 12 option C. And no beta, today I am having some issues with my board. So I have not stopped teaching. I guess within 2-3 days the problem will be solved. Okay. All right. Now you don't have to do this maths. Can you see that it is so obvious? This is so verbal question. Can you see this is a verbal question? Okay. So 2 4s are 8. So you just multiply 4, you will get it. 2 4s are 8. So you are multiplying something. Minus 3 multiply 4. So 12. And this is 1 multiply 4. So you are actually multiplying 4 and you are getting everything. So that's why minus 12. AB cos theta, ma'am. Holika, no, this is AB cos theta is dot product. We are not, like, we have not touched dot product yet. We are just talking about parallel vectors, right? Okay. All right. Now position vector. Understand what is a position vector. Okay. So position vector, suppose there is a point x comma y comma z in a plane. Okay. This is x, this is y, and this will be your z. Okay. So now x comma y comma z. Now position vector. So this is suppose P and this is your O. So position vector of point. Position vector of point P is OP vector. Position vector of point P is what? OP vector. So this is your O, this is your P. OP vector. This is going to be xi cap plus yj cap plus zk cap. Okay. All right. Xi cap, yj cap, zk cap. So this is what your position vector is going to be look like. Okay. Now suppose you are having two points, basically P and Q, and you have to write PQ vector. So PQ vector is minus position vector of P vector. This is different. PQ vector is not PQ. That is vector minus OP vector. Understand what I'm trying to say. This is your OP. This is X1, Y1, Z1. This is your OQ. X2, Y2, Z2. Okay. If I ask you that what is position vector of P, you will say, okay, ma'am, that is X1 I cap plus Y1 J cap plus Z1 K cap. Correct. Position vector of Q, you will tell me, ma'am, clear, X2 I cap, Y2 J cap and Z2 K cap. Correct. Now, PQ vector will be position vector of Q. This is a reverse thing. Okay. Reverse thing is happening. PQ vector is position vector of Q minus position vector of P. So this will be X2 I cap plus Y2 J cap plus Z2 K cap minus X1 I cap plus Y2 Y1 J cap plus Z2 K cap. So what are you going to get? Tell me. What are you going to get? So suppose let's do one question. One question. If point P is this and point Q is this, can anybody tell me what is PQ vector? So it is very easy. Q minus P you have to do. So ma'am, 1 minus 2 minus 1 I cap. Then 2 minus 1. 2 minus 1 is 1 J cap. 4 minus 3, 1 K cap. Yes, getting it? Can you calculate PQ vector for me? Hi Rutika, how are you? PQ vector clear? PQ vector will be what? OQ vector minus OP vector. So OQ vector is what? I cap plus 2J cap plus 4K cap minus 2I cap plus 3K cap. And if you take minus, you will directly get this. Yes, Janardhan, absolutely, absolutely. Okay. Now let us talk about the next topic, which is coplanar vector. Little definitions we are understanding. Okay. Can anybody think about it? What are coplanar vectors? By the name only we can guess, right? That two vectors are always coplanar if they lie in a same plane. If they lie in a same plane. Two vectors are coplanar vectors if they lie in same plane. Coplanar vectors if they lie in same plane. Okay. So two or more, basically three or more vectors may not be coplanar. Okay. So basically understand. Two vectors are always coplanar. Okay. Two vectors are always coplanar. If I just draw two vectors now, then you can create a plane out of it. You take any two vectors in a straight line. No, Holika, understand. No. Think about it. See, suppose I am giving you two vectors. These are the two vectors, two random vectors. Okay, this and this. Now, can you just create a plane out of it? Yes. The third vector will be placed in such a way that it can go wrong. It can become in a completely different plane. It can be in the same plane, but it can be in a different plane. Okay, so understand, two vector will always lie in same plane, but three or more vector may be coplanar, may not be coplanar, depends. Yes, so basically coplanar vectors, I guess that it is clear. Now angle between two vectors, so basically if you are having two vectors like this, who connected? Can you see tail of one vector is connected with tail of another vector? Then this angle will be theta. This is your A vector, this is your B vector, and your theta will be A vector angle B vector. This is how you write. Angle between two vectors is written like this. Okay. But the point is that tail should be connected. Now, if I just tell you that this is the vector and this is the vector, can you just tell me that and this angle is 120 degree. My question is find angle between A and B in this case. This is A vector, this is B vector. So now the angle between these two vectors is not at all 120 degree. Angle between these two vectors is not at all 120 degree. Okay. Okay. So now what you have to do is you have to like shift this vector, because in mathematics they are free vectors. You can shift this. So what I am doing is this A vector, I am just shifting this line in such a way that now this A vector is like traveling and it is becoming this. So basically this line is right here now. Now this is A vector. This is your new A vector. Can you see? And now B vector is there, then and there only. I am not disturbing B vector. So now can you see tail of one vector is connected with tail of another vector? Right? So you guys are telling me, yes, Magnus, you are not doing correct answer. Yes, Magnus, now you have given correct answer. So this angle will be angle between, so 60 degree will be the angle between two vectors. Okay. All right. Yes. Now I will give you, yes, I will give you this. One more question on the way. One more question. This is 30 degree. Find again angle between two vectors. Can anybody tell me about this angle? Yes. So again, this is 30 degrees, not at all an answer. Why, ma'am? Because tail are not connected. Final point are connected. So what we need to do is we need to just move this vector in such a way that it is taking this position. And I'm going to move this vector, this vector in such a way that it is going forward like this. Okay, are you able to imagine? Now, if this is 30, this is also 30. Oh, okay, ma'am. Okay. So now the angle is still 30 degree, but in that manner, this was not connected basically. No, Aditya, it is not 150 degrees. Surprisingly, it is 30 degree only because in the final situation also tail connected, the angle is what? No, Holika, it is 30 degree. Yes, Rutik, you can do that. Theory of equations. Don't worry. Now, magnitude. You must be hearing, ma'am, okay, vector is magnitude, direction. But what the hell is magnitude? Let us know what is the magnitude. So, in 2D we have studied, so there is a point x comma y. And if this is a point, then OP, the position vector of point V will be xi cap plus yj cap. Okay. So now the OP, magnitude of OP, who will tell me? Basically, magnitude of OP is nothing but length of OP. So length of OP, that means origin and point x comma y. Distance formula I can apply. That is going to give you x square plus y square. So this is what your 2D will be there, right? This was in 2D. But what will happen in 3D? Okay, ma'am. So in 3D, obviously you will have x comma y comma z. This is again point P. This is again point O. OP vector will be what? Xi cap, yj cap, zk cap. And OP magnitude will be square root of x square plus y square plus z square. Getting it? Okay. This is your OP magnitude. So 2D and 3D, just one term difference is there, z square, nothing else. Okay. And now if you are having 2 points P and Q. Okay. So this is x1, y1, z1. This is x2, y2, z2. PQ vector, can I write PQ vector as x2 minus x1 I cap plus y2 minus y1 j cap plus z2 minus z1 k cap. Now can you just let me know what is the magnitude of PQ vector? Magnitude of PQ vector is just, remember the distance formula? Distance formula, do you remember? Yes. So it is going to be x2 minus x1 square plus y2 minus y1 square plus z2 minus z1 square. That's it. That's it. Okay. Yes, Martin. What is your doubt? Chalo. Are we ready for a question? Are we question ready now? Are we question ready now? Are we a question ready now? Chalo, let's answer this. Find the vector in the direction of this vector that has magnitude 7 units. Okay. So it is very easy. Okay. So first of all, unit vector. Can anybody tell me unit vector in direction of a vector? Will be what? Ma'am, unit vector in direction of a vector will be a cap, and that is equals to a vector upon magnitude of that vector. Okay, fine. So let us apply this formula. This is I cap minus 2j cap is your a vector upon square root of 1 square. 1 plus 2 square is what? 5. Okay. This is your unit vector, by the way. But they are not asking you unit vector. They are asking you about vector of magnitude 7 units. So your answer will be 7a cap. 7 multiply a cap. Now 7a cap will have what? Tell me. And 7a cap will have direction of a vector only. Direction, so we have not changed. And magnitude will be 7 and a cap. So 7 into 1, 7. Right? So find, yes, absolutely, Ragul, you're absolutely right. You have found vector, unit vector. Now multiply it with 7. That's it. Multiply it with 7. That's it. No. So this is 7 I cap minus 14 j cap upon root 5. Yes, Holika, what is the doubt? Yes, Sanjay, till 8 p.m. How can I super chat of 5,000 to you? Because you're looking beautiful and your teaching is too good. Somebody can, somebody please guide him how to do super chat. I don't know. I don't know. Okay. All right. Now, okay. So that's it. That's it. Now, another thing which is section formula. Okay. So section formula may suppose you are having a line segment PQ. Suppose you are having a line segment PQ, right? And there is a point R which is dividing this line segment PQ in n m is to n ratio. Then the position vector of R, that is R vector, will be what? So again, do you understand this in your like straight lines chapter? Same. It's just that a few changes will be there. M into Q plus n into P upon M plus N. This is internal division. Okay, when the R points lie in between PQ. This is the section formula. And now for external division, this is your P, this is your Q. Now, what is happening? So basically, your line segment PQ is divided by this point R externally in m is to n ratio, m is to n. So again, what will you do? R vector will be equals to m into m into q minus n into p upon m minus n. Just that. Okay. Yes. Yes, Janardhan, ask me any doubts. Okay, so this is what your section formula will look like. Now let us do one question on section formula because you guys were not paying attention when I was teaching you. Huh? Let's see how many of you paid attention. Point R divides the line segment PQ internally in the ratio 2:3. Okay. So this is your P, this is your Q. There is a point R which divides PQ internally in what ratio, ma'am? 2:3. Now position vector of R you have to figure out. Okay. Position vector of R will be 2 into Q vector plus 3 into P vector upon 2 plus 3 is 5. So R vector is 2Q. So 2Q will be twice of I minus J minus K plus 3 times I plus J plus K upon 2 plus 3. This is your R vector, right? So 2 plus 3 is 5 I cap. Minus 2 plus 3 is plus I cap. Minus 2 plus 3 is plus J cap upon 5. Ma'am, I am ma'am. Praveen Kumar Janardhan. No, I don't. What is your doubt? Okay. So everybody got this? Everybody got this? That how to figure out. This is K. Sorry. Final one is K. Okay. So how to apply section formula? Give me a big thumbs up if you have understood this. Okay. All right. All right. Vedang is asking calculus के सवाल नहीं बन पाते. What to do? We'll take some session on calculus. Do not worry about that. Okay. Once the syllabus is done, then we'll take problem solving sessions for calculus. Okay. So you'll be able to do that. Chalo. Now we are having a triangle A, B and C. A is having A vector, B is having B vector, C is having C vector. Correct? Okay. And this is the centroid. Centroid. Okay, the centroid, position vector of centroid of any triangle G is what? A plus B plus C by 3. You have to remember it. And also there are some properties. So basically centroid, how a centroid is formed, do you know? So first of all, you have to drop a median. This is AD is median where BD and DC are equal. One thing. This is your centroid which divides the median in what ratio? 2:1 ratio. Okay. And this is A plus B plus C by 3. Okay. All right. Yes. Now, in center. Position vector of in center. Again, a triangle is given to you. This is A vector. This is B vector. This is C vector. And one more thing, do not forget about it. The side which is in front of A vertex is small a. Side which is in front of B vector is small b. And this is small c. Okay. Or rather, let me just write it as x, y, z. It will be better, right? So now x, position vector of in center will be what? The meeting point of angle bisector. Okay. Meeting point of angle bisector. Meeting point of angle bisector. Correct? Now, the position vector of in center will be what? Ma'am, x, the side multiply opposite vertex, xa plus yb plus zc upon x plus y plus z. That's it. Okay. All right. This is your position vector of in center. Now, there will be, I was telling you, remember that, okay, angle is not at all what? Angle is not a vector quantity. I gave you reason because it does not obey vector law. Vector law. Vector law. What are vector law? Vector laws are triangle law, parallelogram law. These are the vector law. Okay. So now triangle law is something which is very important, and on top of it, parallelogram law is also a vector law. But we will not study triangle law. We will not study parallelogram law. We will study what? Loop law. Loop law supremacy. Loop law supremacy. Okay. This is loop law supremacy. Spelling is correct. Okay. All right. Loop law supremacy. What is loop law? See, this is, suppose you are having this. Okay. Suppose you are having this situation. This is your A vector. This is your B vector. This is, and this is your C vector. Correct? A vector, B vector, and C vector. Correct? Now, loop law says that do not think about anything. Just think about direction. If you are going, in the same direction with the vector, apply positive sign. If you are going vector, apply negative sign. I will show you how. Okay. So what we need to do is we need to understand B and C. Understand the relation between A, B, and C. So you pick any point, any vertex. You pick any vertex. Okay. So you want to start from here, do it. You want to start from here, do it. You want to start from here, do it. Okay. I will teach you all possible starting points. Let's pick a starting point. Let's start from here this time and let's go anti-clockwise. Okay. And let's write down the relation. Okay, ma'am. So we are like starting from this point and we are going towards A vector. Now, am I going in the direction of A vector? Yes, ma'am. So apply plus A vector sign. Okay. So we are going till here. And then now I have to go parallel B. So am I going in the direction of B vector? Yes, ma'am. So plus B vector. Okay. And now if I just go towards C, so can I get to C? So it can't be plus. It has to be minus. Minus C. And once the loop is completed, now you have to put a 0. Are you getting my point? How does the loop law works? Okay. Let's do it one more time. Same question, but some. Okay, ma'am. Hold on. What is happening? Yes. So this is, okay, hold on. This, what is happening? Why my pen tab is acting up? Okay. A vector, B vector, C vector. Again, okay. And we are going to do loop law. But this time, let us start with some starting point I am changing. Let us start with this. Okay. So now I will start with this and I will go like this. Okay, ma'am, hold on. Now if you start with this and you have to go like this. So you are going against a vector. So ma'am, it should be minus a vector. Okay. Then ma'am, you are going, before coming this, you will go like this. You have to complete a loop. Okay. So now C vector, are you going with C vector? Yes, ma'am. So it will be plus C vector. Okay. And then coming back. So again, you are coming against B vector. So that's why minus B vector. And once the loop is completed, you have to write 0. Is it making sense? Yes. So again, can you see both equations are exactly same? You are getting same result, isn't it? Tell me if you have understood it. Anybody having problem in loop law? So you just have to complete the loop no matter what starting point you keep. And if you are going with that vector, write plus sign. If you are going against that vector, write negative sign. Complete the loop. Once loop is completed, you have to submit 0. Right hand side is 0. Okay, chalo, let's see how many of you have understood this. Let me give you a question. Okay. So suppose you are having, so it will like loop law is like above all. It will include triangle law. It will destroy parallelogram law. Okay. Chalo, let's start now. I'll be giving you a question. What is happening? Question. A vector, B vector, C vector, D vector. Tell me the final relation. Tell me the final relation. Okay, let's start. From where do you want to start? Tell me. Okay, ma'am, let's start from here and go like this. So it is against D, so minus D. Minus D, then plus A, plus B, plus C. Minus D plus A plus B plus C equals to 0. Are you guys getting it? Are you guys getting it? Same. This is your loop law. Okay. Now collinearity of 3 points. What will happen if 3 points are collinear? 1, 2 and 3. Okay. So 3 points will be collinear if they both will lie on the same line. How will you prove? How will you derive a condition for a vector, like in terms of a vector? So suppose this is your A, this is your B, this is your C. So what if I tell you AB vector and BC vector? AB vector and BC. AB is this, BC is this. Can you see AB and BC vector are sharing same direction? Yes. I don't know about the magnitude, but definitely the direction is absolutely same, right? So AB vector will be lambda BC vector, my dear students. AB vector is lambda times BC vector, right? AB vector is equals to lambda times BC vector, same direction. Okay. Thank you guys. Thank you Hulika. Thank you Harini. Thank you Mochumi. Moshumi. Is it Moshumi? Mochumi. Okay, let's do one question. Okay. We'll try to finish this session off before 8 p.m. Harini. Okay. Chalo, let's do this question. 2a vector minus 3b vector. B vector and A minus B vectors, these three are not vectors, but the position vector of 3 points A, B and C. Understand what they are trying to say. This is your point A, this is your point B, this is your point C. Now A, B, C can either be collinear or non-collinear, right? So if A, B, C are collinear, AB vector will be equals to lambda times BC vector. Now AB vector will be what? AB vector will be position vector of B. So this is A, this is B, this is C. Okay. Now this is your AB vector will be B minus A. So that is going to be b minus 2a minus 3b, correct? Is equals to lambda times. Now b minus bc vector will be c minus b. So this is a minus b minus b vector. So a minus b minus b vector. Okay, ma'am. Right? So this is basically b minus a is equals to lambda times c minus b. This is what we have done. Yes? Okay. And now this is going to become what? On the left hand side, can anybody tell me? This is going to become 2b minus 2a is equals to lambda times. In here, what you are going to get, tell me. So this is a minus b minus b. So this is going to become bc vector. Hold on. Have I done anything wrong? Okay, so this is sorry. There is some calculation mistake you are not telling. Okay. And what about this? This is going to become a minus 2b. Now, can you understand? Can you understand this? If I take minus 2 common from here, this is going to become what? A minus 2b only. Lambda times a minus 2b, right? So here, lambda is coming out as minus 2. What does that mean? That AB is equals to lambda times BC is becoming true. Okay. So that means they are collinear because it is satisfying this condition. If lambda becomes 0, that means this condition is not true. AB vector is not equal to lambda times B vector. This means AB vector is equals to lambda times BC vector is not true. This implies that these three vectors are non-collinear. Do you understand the condition of collinearity and non-collinearity? Yes, Sachin, thank you. Do you understand the condition of collinearity and non-collinearity? Okay. All right. Now, if you understand now, then let's do one more question. Are we ready for it? Are we ready? There is this A vector, there is this B vector, there is this C vector. Okay. And they are collinear vectors. What is the value of P? So understand what is happening. Again, and AB and BC vector is not making any sense. AB and BC is not making any sense. Don't go with BC vector, please. It's a common sense, right? See, let me just go back and tell you that here we are talking about AB and BC. But can we talk about AB and AC? Are these two also parallel? Yes, ma'am. So that means either I apply AB is equals to lambda BC or I apply AB is equals to lambda AC. Both will work. Yes. It depends that what your situation is. So right here, you apply your brains. See, AB, B vector is unknown. So you can't be putting that unknown vector every time. You want one unknown and one known. That will make more sense. Yes or no? So AB and AC vector will make more sense. Now AB vector, tell me, to ma'am, AB vector will be P minus 2 I cap and 9 minus 3, so plus 6 j cap. And what about AC vector? C minus A, ma'am. So I minus 2, so minus I cap. And this is minus 1 minus 3 minus 4 j cap. Okay. So this is AB, this is AC. Okay. So AB will be equals to, right? Okay. So that means P minus I cap plus 6 j cap will become lambda times minus I minus 4j. Now clearly if you compare, you will realize what will happen. So 6 is equals to minus 4 lambda. If you compare it, what will happen? 6 equals to minus 4 lambda. So lambda is minus 3 by 2. And here P minus 2 and minus lambda will be equal. P minus 2 equals to minus lambda. So P minus 2 equals to minus 3 by 2 plus 3 by 2. So P will be equals to what? 2 plus 3 by 2. 2 2s are 4 plus 3, 7. So this is 7 by 2. Tell me it is clear or not? Yeah, this is a PYQ. This is a PYQ, but this PYQ is quite old PYQ. Okay. Telegram link I'll be, okay. Telegram link, okay? So if you want to follow me on Telegram, write t.me/Namrata, Namrata, JAYSINGHANI. Okay? All right. Now there is actually one more way, one more easy way. Are you ready for that easy way? Tell me. Are you ready for that easy way? Actually, easy way is this only. Same. P minus 2. See, AB vector is what? AB vector, tell me. AB and AC we are doing. AB is equals to lambda. Yes, Harini, one more time we are doing it. Okay, AB vector is equals to AC vector. Do you understand this statement if 3 points are collinear? Yes, ma'am. AB vector is what? B minus A. So B is P minus 2 and 9 minus 3. So P minus 2 comma 9 minus 3 is 6. I and J is equals to lambda times AC vector. Now AC vector is what? C minus A. So C minus A will be 1 minus 2 minus 1 and minus 1 minus 3 is minus 4. So minus 1 comma minus 4. Again, this is I, this is J, I and J. Now we are comparing the I corresponding things. So P minus 2 is equals to minus lambda first and 6 equals to minus 4 lambda. So lambda is minus 3 by 2 from here. You get and put here. P minus 2 is equals to what? You are going to get 3 by 2. P equals to 2 plus 3 by 2. 2 to the 4. P will be equals to 2 to the 4. 7 by 2. Okay. All right. Clear. Now we are here for dot product, my dear students. Dot product. Dot product. Are we ready for dot product? Tell me in the chat box. Are we dot product ready? Or do we need one more question? Okay, before that, let's do one more question, okay? Let me give you one more question. This is from JEE Main 2023. JEE Main 2023. Okay. So the question says if the points with position vector, if the points with position vector alpha I cap plus 10 j cap plus 13 k cap and 6 I cap plus 11 j cap plus 11 k cap and 9 I cap plus beta j cap minus 8 k cap are collinear. Then you have to find the value of 19 alpha minus 6 beta whole square. This was asked in JEE Main 2023. Okay. Question based on collinearity. You will get a PYQ in your JEE Main 2025 as well. Now, if 3 vectors are collinear, then it is very obvious AB vector will be equals to lambda times BC vector. Okay, what is AB vector, ma'am? AB is 6 minus alpha, comma 1 because 11 minus 10 is 1 and 11 minus 13 is minus 2. Perfect. Is equals to lambda times. What is BC vector? This is B, this is C. See, this is A, B and C. Now 9 minus 6 is 3, beta minus 11 and minus 8 minus 11 would be what? Minus 19. Yes. Now compare. 6 lambda. 6 minus alpha equals to 3 lambda. That is equation number 1. 1 is equals to lambda times beta minus 11. So 1 equals to lambda times beta minus 11. This is your second equation. And what is third? Minus 2 is equals to minus 19 lambda. Third equation. By third equation, I am getting my lambda, which is 2 by 19. Now, where to put this lambda? Tell me. So, it is so obvious that I'm going to put lambda over here to get the value of alpha. So, now, let's come here. 6 minus 3 lambda equals to alpha. So, 6 minus 3 into 2 by 19 equals to alpha. And this is 6 minus 6 by 19. So 19 minus 1. So this is going to become what? 18 by 19 into 6 is your alpha. What is alpha coming? Have I done it correct? Lambda is coming out as what? Lambda is 2 by 19. That is correct. Alpha is coming out as sorry, this is 9 by 2. Hold on, there is a mistake. AB and then C minus B. So this is 9 by 2 minus 6. Right? So BC vector is 9 by 2 minus 6. So 6 2s are 12 minus 3 by 2. So basically this is minus 3 by 2. Okay, so the first equation is minus 3 by 2. There is some mistake. So minus 3 by 2. So this is basically plus 3 by 2. So let me just delete it a little bit. Hold on. This is plus 3 by 2. And now 6 plus 3 by 2 into 2 by 19 is alpha. So alpha will be what? 16 into 19 into 6 plus 3 by 19 is your alpha. Okay. Perfect. What about beta? How to calculate beta? Again, I'll be using second equation for the beta. So beta will be what? Beta, to get the value of beta, you have to solve 1 equals to lambda beta minus 11. Now, what is lambda? Lambda is, ma'am, 2 by 19. So, this is 19 by 2 is equals to beta minus 11. So, beta will be what? Is it visible? Beta, you will get it from here. Now, just plug in the values, okay? 19 alpha minus 6 beta. 19 alpha minus 6 beta whole square, okay? So, 19 alpha. Alpha is what? Alpha is 19 into 6 plus 3 by 19. 19 alpha minus 6 times beta. Let me catch beta over here. So 19 by 2 plus 11. 19 by 2 plus 11 is your beta. And there is a whole square involved. Okay, there is a whole square involved. Correct? So what are you going to get? Okay, so this is going to be 19, 19 cancel. This is 19 multiply 6 plus 3 minus. If you multiply 6 inside, this is going to be 3 multiply 19 and minus 66 whole square. Correct? Now let's keep them together. These two together. So 19 into 6 and 19 into 3. 19 into 3 plus 3 minus 66. So that is going to give you minus 63 whole square. So this is 9 3s are 27. 57 minus 63 whole square will become what? So this is 6 ka square, that is 36. Is 36 is in the answer? Absolutely. Why not? So 36 is the correct answer of this question. Understood? Yes, Gina, you are here. Very nice. Okay, sorry for the mistake. I made a mistake. 9 by 2 I didn't keep. So this is 9 by 2. Yes, Gaurav. Hi, Gaurav. How are you? Okay. All right. Now let us talk about dot product. Very, very important. Huh? So dot product. What is a dot product? So basically dot product looks like this. You have a vector, you have a dot, and you have a b vector. A dot b. Dot product is also called as a scalar product. Okay. All right, so A dot B is AB cos theta. Why it is called as a scalar product? Basically, we are doing some operation in two vectors and the resultant we are getting is, a scalar quantity. AB cos theta is a scalar quantity. A is magnitude of A, B is magnitude of B and cos theta. Okay, so now theta here is angle between A and B. This is your theta. Angle between A vector and B vector is your theta. Okay. Now A dot B. What will happen to A dot B if the angle varies? The case number one. Case number one, if your theta is acute angle. What is an acute angle? Theta belongs to 0 to 90 degree. Okay. So if theta is 0 to 90 degree, obviously your cos theta, right hand side, AB cos theta, you're doing cos theta. So cos theta in first quadrant, cos theta, because theta is lying in first quadrant, right? So theta lying in first quadrant, so cos theta will be positive, and obviously A and B are magnitude, that's why they are also positive. So clearly the right hand side, A dot B, is A B cos theta. A is positive, B is positive, and cos theta is also positive. So basically your A dot B dot product is positive. So whenever you see bhai dot product is greater than 0, then you will have to understand that dot product 0, that means theta between, angle between them is acute angle. Okay ma'am, got it. Now case number 2. When theta is 90 degree. Okay, when theta is 90 degree, right? So when theta is 90 degree, when 90 degree, A dot B will be AB cos theta, right? That is going to give you what? Theta is 90 degree. This implies your cos theta is cos 90 degree. That is 0. Right angle, right? So two perpendicular vectors, the dot product between them will become 0. Very, very important. If A is perpendicular to B, will you be able to remember it? If A and B are perpendicular to each other, what does that mean? That their dot product should be equals to 0. Very, very important. Okay. Now case 3. When your theta is obtuse, that means theta is lying between 90 to 180. Okay. All right. So cos second quadrant, angle is in second quadrant. Okay. So negative. Cos negative. ASTC rule. Remember all sine tan cos. In second quadrant, cos is negative. So A dot B will give you again AB cos theta. A is positive, B is positive, but cos theta is negative. 2 negative. That means A dot B, whenever I tell you that A dot B is negative, you will say, okay, A dot B negative, that means the angle between those two might be obtuse. 100% is obtuse, might be is not the case. 100% ma'am, it is obtuse. If A dot B is positive, 100% it is acute, right? And A dot B is 0, then, okay. If A dot B is 0, then there are actually 3 predictions. A vector becomes 0 or B vector becomes 0 or A and B are non-zero, but A is perpendicular to B when both vectors are perpendicular to each other, right? Right? When A dot B is 0, so A, B cos theta, 3 things are there. Either this is 0 or this is 0 or this is 0. A is 0, B is 0 or cos theta is 0. So A is 0, that means A is null vector. A is null. B is 0 means B is null. And cos theta 0 means angle is 90 degree. Are you getting it? Yes, little. Okay. Now, how to find a dot product? Ma'am, you are saying that A dot B is this, A dot B positive, A dot B negative. But how exactly are you going to find the dot product? So, formula to find a dot product. Suppose you have a vector A which is 3i cap plus j cap plus k cap. And there is a vector B which is 4i cap plus 5j cap plus k cap. Correct? Now you have to figure out A dot B. It is very simple. You just have to multiply the corresponding components. I cap to I cap, I to I, U to U, me to me, huh? I to I, J to J, K to K, right? So 3 fours are 12 plus 5 ones are 5 and 1 ones are 1. So 12 plus 5 plus 1, easiest of all. Somebody was asking, Harini, are you here? You were asking, na? And dot product is easy or cross? You just, dot product is so easy, right? 3 fours are 12, 12 plus 5, 17, 18. A dot B is coming out as 18. Okay. All right. So formula is what? So if A vector is given A1, B1, C1, I, J, K. And B vector is A2, B2, C2. Then A dot B will be what? Tell me. A1 A2 plus B1 B2 plus C1 C2. Right? Yes. Now properties of dot product. You have to watch this out. Okay. Property 1 says that A dot B or B dot A both are same. Property number 2 says that A dot B plus C is A dot B plus A dot C. Basic properties, right? Just like multiplication. Okay. And this property is very important. If you multiply A dot A, so A dot A will be what? Tell me. So formula is, ma'am, A dot B is AB cos theta. So A dot A is A cos theta. Theta is not there. Angle between A vector and A vector is what? Angle between two same vectors is 0 degree. Cos 0 degree is 1. So this is A1. This is A square. Very important, property A dot A is A square. Remember it. Do remember it. Okay. Now, A dot B. What is the minimum and maximum value of A dot B? Tell me. Okay. Let us understand this. A dot B is what? AB cos theta. A and B are the magnitude of A and B vector. So this is fixed, right? That is fixed. But this cos theta is something very. What is the maximum value of cos theta that you can put? Ma'am, maximum. So A dot B maximum value will be actually AB because cos theta becomes 1. So the maximum value of A dot B is just AB. What about A dot B minimum value? For minimum, you have to put cos theta. So minimum value of cos theta is what? Minus 1. So if you put minus 1 in place of cos theta, this is minus AB. That means your spectrum, like the minimum value of A dot B is minus 1 and maximum will be plus 1. Okay. All right. Clear? And this will happen when theta is 0 degree. Remember, theta 0 degree means what? Like vectors. Remember, theta 0 degree, when theta is 0 degree, when both the vectors are parallel. And here, theta is 180 degree. To get cos theta minus 1, theta is 180 degree, right? Theta 180 degree means unlike vectors. Okay. Unlike vector means one this side, one this side. Okay. All the properties which I am telling you, Harini, these properties are very easy now. You will be able to remember. Okay. Fifth thing is, if you have to calculate two vectors, use this formula. A dot B upon AB. I have a doubt. A vector dot A vector, can we call it as A? No, you are saying. So let me just write it. The third property can be written down as A dot A is equals to magnitude of A square. Yes. Is that what you're saying? Yes, you can do that. That's the most proper way actually. Sixth property. That's it. I guess these 5 properties. Now let's talk about some more properties. Okay, some more properties. So first property will be A dot A will be magnitude of A square. Okay, second property will be A plus B dot A plus B. Tell me, the ma'am, it will be A plus B whole square. Just like this. Just like this. Right? I am just replicating the property. I am just replacing A vector by A plus B this time. Now, A vector, A plus B vector dot A minus B. Tell me. So, ma'am, it's very easy. A dot A. So, you will get what? A dot A is A square. Then A dot B, B dot A will get cancelled out, minus B square. So, basically, or you can write as magnitude of A square minus magnitude of B square. Okay. Some important identities. Now, if A plus B plus C dot A plus B plus C will happen, then what will you do? Again, A plus B plus C whole square. What will that be? This is A square plus B square plus C square. Obviously, this is magnitude, magnitude, magnitude. Plus 2A dot B plus 2B dot C plus 2C dot A. Okay. All right. This is what your properties is. Clear? Now again, what about this? Can anybody tell me? A plus b whole square will be a square plus b square plus 2a dot b. This is a dot product. A student is asking physics का vector समझ के घुस गया तो क्या हो गया? Then do maths and then get out. Come out. Sorry, I was not about to say get out. I said do maths and then come out. Chalo. Anyway, are we ready for the next topic, which is projection? And this is very important topic for vectors. You might see a question from projection as well. Okay. Chalo, very easy topic. It is actually application of dot product. Suppose you are getting a vector B. Suppose you are getting a vector A. And you have to write projection of A vector on B vector. Understand the statement. Here they are saying on B vector. Projection means what? Projection means that you have to, like, suppose this is the whole setup and you have to burn the torch from here. You're watching from the upper. You're watching from here. From the sky you are watching, okay? And you are just showing the torch. This is your torch. You are showing the torch here. And the moment you will show the torch, this is the thing, and the shadow of A vector on B vector. Shadow of length of shadow. Basically, what we are looking for is for the length of shadow. This length, this is the projection. This is the projection. Length of shadow of A vector on B vector. This will be shadow or not? Tell me. Yes, this will be your projection. Now, how to find this? So, to find this, if this is your theta, if this is A cos theta. Remember, physics teacher must have told you the horizontal component, A cos theta. Now, A cos theta, so ma'am, we don't know. What we know is AB cos theta. AB cos theta. So, what I'll be doing is, I'll be multiplying B on numerator and denominator because I want to introduce what? Dot product. Okay. So, AB. So, this is AB cos theta. AB cos theta. Now, AB cos theta, don't you feel this is A dot B? And this B is actually magnitude of B. This is projection of A vector on B vector. Understand? Whenever there is on B vector, in the denominator, you will keep B vector. On B, then B vector will be in denominator. And in the numerator, it will be A dot B. Do you remember the formula? Will you be able to remember the formula? Tell me. Okay. All right. Yes. Let's do one easy question on it. What do you think? What do you think? Let's do one easy question on it. Okay. Very basic question I will give. Find projection of I minus 2j on 3k cap. On 2j plus 3k. Let's do it. Then we will solve a PYQ. Okay. Okay. All right. Projection of I minus 2j on 2j plus 3k. So, projection of this vector on this vector is what you have to do. So, again, this is, let us assume this is your A vector. This is your B vector. And now A dot B upon magnitude of B vector. Okay, this you have to do. Now A dot B, take dot product of A and B. Who will tell me the dot product? I dot B. So there is no I in B vector, right? So A dot B, if I calculate, what will I get? Tell me, ma'am. I dot 0, so 0. Then minus 2j plus 2j is minus 4, and there is no k, so that's why it is 0. So minus 4 is the A dot B upon. Now we want magnitude of B vector. Magnitude of B vector will be square root of 4 plus 9. So this is going to become what? This is going to become what? Tell me. 4 plus 9, 13. Root 13. This is the projection. Okay. All right. Clear? Yes, Gina, you have given me incorrect answer earlier. Harini, where is square root? Harini, where is square root? You guys are making silly mistakes, huh? All right. Let's do one question now. JEE main PYQ projection pay. You will definitely sure shot get a good chunk of questions, right? Okay. All right. Now, if alpha vector, no key to type square root in laptop. Okay. Chalo, alpha vector is given to you. Now, understand this question nicely. This was asked in JEE main 2023. Alpha vector is given to you. Beta vector is also given to you, right? This is your beta vector. And beta 1 be parallel to alpha vector. Okay, hold on. Understand this. Beta 1 vector is parallel to alpha vector. Can I just write beta 1 vector is equals to lambda times alpha? What do you guys say? One information I got. Beta 1 is equals to lambda times alpha vector. And from here, I can get beta 1 equals to lambda times alpha. What is alpha? 4, 3, 5. This is your alpha. So beta 1, we are getting this. Okay. All right. So now this is your beta 1. This information, we have used it. Next, what is next? Because alpha, beta they are giving. What is next? They are talking about beta 2. Can you see? Beta 2 vector. Now they are saying beta 2 vector is perpendicular to alpha vector. Okay, hold on. One more information. Beta 2 vector is perpendicular to alpha vector. What does that mean? Can anybody tell me? Can anybody tell me? When two vectors are perpendicular to each other, dot product between them becomes 0. Yes, how many of you have thought about it? Beta 2 and alpha, dot product becomes 0. Okay, ma'am. One more information. This piece of information already used. Now, beta 2, what is beta 2? Where is beta 2? I can't see beta 2. But now further, if I study that beta vector is beta 1 plus beta 2. See, beta vector they are giving. Beta 1 I have calculated. Beta 2 is something that is still unknown. Now, beta 2, can I just write beta 2 is equals to beta minus beta 1? This is very important. Beta 2 is beta minus beta 1. Why, ma'am? Why exactly? Because I have beta and not the proper form, but I still have something. What I don't have is beta 2. Right? So, beta 2 is beta minus beta 1. Beta 2 is beta minus beta 1. So, what is beta? Beta is 1, 2, minus 4 minus lambda times 4, 3, 5. Right? So, this is going to give you 1 minus 4 lambda, comma, 2 minus 3 lambda, comma, minus 4 minus 5 lambda. This is your beta 2 vector. And now I'll be using this thing, which is this. Dot product between beta 2 and alpha should be 0. Now watch me carefully. Where is beta 2, ma'am? Here. So it will be 1 minus 4 lambda, comma, 2 minus 3 lambda, comma, minus 4 minus 5 lambda. Okay, this is your ma'am beta 2. Yes. Dot, now you have to take the dot. You have to take the dot with what? Alpha. Where is alpha? Where is alpha? 5. 4, 3 and 5. Dot product between them becomes 0. Now if I take dot product, here is the good news. I will actually get the value of lambda. Once I get the value of lambda, I will actually get beta 2, beta 1, everything I will get, right? Beta 1, beta 2, everything. Now what they are asking is beta 2 dot ijk. Okay, so beta 2 I will get once I get the value of lambda, and the question is done. Now the last thing, just find dot product 0, calculate the value of lambda. So this multiply this, 4 minus 16 lambda, this multiply this, plus 6 minus 9 lambda, this multiply this, minus 20 minus 25 lambda equals to 0. Okay. So this is going to give me what? 4 minus 20. Okay, 4 plus 6 is 10. 10 minus 20 is minus 10. Then we have minus 16 and minus 9. Minus 25 and so minus 50 lambda. Am I doing correct, guys? Lambda is coming out as 1 by 5 with a negative sign. Yes or no? Okay, lambda is minus 1 by 5. Now, what you need to do is, you need to just plug in the value of lambda over here and find out B2. Let's find out B2. B2 is what? B2 will be equals to 1 minus 4 lambda, comma 2 minus 3 lambda, comma minus 4 minus 5 lambda, and lambda here is minus 1 by 5. Let's plug in and get B2. B2 will be equals to 1 plus 4 by 5, comma 2 plus 3 by 5, comma minus 1. Okay. So beta 2 is actually 9 by 5, comma 5 2s are 10, 13 by 5, comma minus 3. Now you have to take dot with alpha. Okay. So this is your actually beta 2. Beta 2 is this. Now you have to take dot with alpha. Let's take dot with alpha. Dot with alpha. Sorry. You have to take dot with I plus j plus k. Right? I plus j plus k and multiply 5 also there. So 5 dot beta 2 dot this. So 5 multiply this dot I plus j plus k. If I just calculate the dot product, you will get 9 by 5 into 1. 9 by 5 plus 13 by 5 minus 3, and there is 5 outside. So if you multiply 5, 9 plus 13 minus 15 will give you what? Will give you what? 9 plus 13 minus 15. 21 minus 15. 21 minus 22 minus 15 is your 7. 7, 7, 7. Ma'am is here. Ma'am is here. Don't worry. Ma'am is here. Ma'am is back. So when I write on this partner, whenever the text, the ink is missing, so I disappear. Guys, what are you doing? Are you guys just learning how to write square root in this chat box? Waste of time, waste of time. You can just write SQRT 13. That's it. SQRT 13. Chalo. I guess we are done with this now, right? One more question on projection. JEE 2020, one more question on projection. Are we ready for it? Are we up for it? Okay. One more question. JEE 2020. Question says, let the vector A, B, C are such that A vector magnitude is 2, B vector magnitude is 4, and C vector C vector magnitude is given as 4 again. Now, if the projection of B vector on A vector is equal to projection of C on A, projection of C vector on A vector, okay, and B is given as perpendicular to C vector, then we have to figure out the value of magnitude of A plus B plus C. This was asked in JEE in 2020. Hello Hema, how are you? Okay, let's start doing this question. A magnitude given, B magnitude given, C magnitude given. Projection of B on A is equals to projection of C on A. So projection of B on A will be what, ma'am? B dot A upon magnitude of A. Because B on A, whenever on A is there, so denominator mein we will write A equals to projection of C on A. So C dot A upon again A magnitude of A. Magnitude of A can be cancelled. So what we are getting is B dot A is equals to C dot A. Acha, okay. Now can I just do one thing? Because I can see A vector both are here. So can I just write B vector minus C vector. B minus C vector dot A vector is 0. Can I write it this way? Okay. Dot product between B minus C and A vector, did you just write it as 0? Yes. Dot product B minus A and A vector, what does that mean? That A vector is perpendicular to B minus C vector. These two are actually perpendicular vector, right? A is perpendicular to B minus C. Okay, hold on. Now, can I just do one thing? What I'll be doing is, I'll be taking magnitude of A plus B minus C. Yes, magnitude of A plus B minus C. Okay. Hold on, ma'am. Hold on. Why are you doing that? Because and square. I am going to use a very important property over here. Okay, A plus B minus C whole square. Basically, B minus C, I'll be keeping B minus C as a single term. A as a single term, B minus C as a single term. Now square. Do you remember the property? Magnitude of A square, yes ma'am. Plus magnitude of B minus C whole square, yes ma'am. Plus 2 times dot product between them. 2 times A dot B minus C equals to 0. Ma'am, what did you just do? So I made use of this thing, that if I just square A plus B minus C, then there will be a thing A dot B minus C that is 0 because we have obtained it from here. Okay. And now what will be this B? So this is A square plus, now B minus C whole square. Again, can I just open it? This is going to become what? B square plus C square minus 2B dot C. Yes or no? B minus C whole square. B minus C whole square is what? Tell me. Ma'am, B square plus C square minus 2B dot C. Now, can you see as per the question? B is perpendicular to C. What does that mean? B dot C will be 0. That means this is also 0. So, here you are getting A plus B minus C whole square will become what? A square plus B square plus C square. Okay, so this is going to become, actually what you have to figure out is not A plus B plus C, but A plus B minus C is what you have to figure out. Yes. So now A plus B minus C whole square. A plus B minus C whole square is what? A square plus A plus B minus C whole square is A square, that is 4 plus B square 16 plus 16. So this is 16 और 16 32 plus 36. Square will be cancelled. So this is square root of 36. That is 6. 6 will be absolutely correct answer. Just tell me if you have understood or not. Yes, Harini, I don't count. You tell me how many questions we have solved in this session. You tell me. Okay. Done with this question? Yes. Now we are having, okay, hold on. We are having, yes, another thing on our screen. Okay. Linear combination of vectors. Okay. Very important. It is also called as theorem in plane. Theorem in plane says if A vector and B vector are two non-zero, non-collinear vectors, then, so basically, if there are two vectors involved, understand. Forget about the lines, forget about the theory. Okay. If there are two vectors, then there is the third vector which is lying in the plane of A and B vector. What you can do is the third vector. Suppose this is a R vector. Third vector can be expressed as some scalar multiply first vector, some scalar multiply second vector. R vector is XA vector plus YB vector. R vector is XA vector plus YB vector. Okay. Oh Bhavesh, you are late. कोई बात नहीं. You can watch this whole session in recording as well. Don't worry. Okay. Do you understand theorem in plane? Very important. By the way, this is important theorem. Why I am saying this is important? Because you won't even know where to use it. I am going to tell you that whenever you see this line, there is a vector which is lying in plane of given two vectors. Use this. Are you understanding where to use? Or you can just see that a vector is in is coplanar with two given vectors. A vector is coplanar with two given vectors. Then use this theorem in plane. Okay, let's do one question. Okay, then only you will understand. Are we ready for one question? Okay. All right. Now, can you see this is JEE Main 2021 question which says X vector be a vector in the plane containing A vector and B vector. X vector be a vector in the plane containing vectors A and B. Okay, okay. So that means X vector will be what? Tell me. Lambda times 2 comma minus 1 comma 1 plus mu times 1 comma 2 comma minus 1. This is how I wrote using theorem in plane. How many of you have understood this? How many of you have understood theorem in plane? Let me know in the chat box. I will wait because this is absolutely important. Absolutely important, right? So this is your X vector. X vector, let me just tell you one more time. 2 lambda plus mu, comma minus lambda plus 2 mu. And this is going to give you lambda minus mu. Yes, this is your X vector. First statement is clear to you all. Next, if the vector X vector is perpendicular to 3 comma minus 1. So now they are saying X vector is perpendicular to 3 comma 2 comma minus 1. 3 comma 2 comma minus 1. What does that mean? Dot product is equals to 0. Dot product is equals to 0. All right. So X perpendicular to 3 comma 2 comma minus 1 dot product 0. So let's do it. Let's do the dot product 0. So 2 lambda plus mu, 2 lambda plus mu, comma, minus lambda plus 2 mu, comma, lambda minus mu. You will do a dot product with 3 comma 2 comma minus 1 and this will become 0. So your answer will be 3 to the 6 lambda plus 6 mu minus 2 lambda plus 4 mu minus lambda plus mu equals to 0. Okay. 6 lambda minus 2 lambda is 4 lambda. 4 lambda minus lambda is 3 lambda. Okay, ma'am. 3 plus 4, 7. This is plus 8 mu equals to 0. So we've got a beautiful relation between lambda and mu. Can you see this relation between lambda and mu? 3 lambda plus 8 mu is 0. Let us keep it aside. Okay, now one more information they are giving. The last information says that x is perpendicular to this vector and its projection on a vector is given. Hold on. Now they are saying that projection of x vector on a vector is what? 17 root 6 by 2. That is what they are saying. That means x dot a upon magnitude of a is this 17 root x by 2. Now x. Tell me about the x vector. So x vector will be what? Tell me. So x vector we have just figured out. It is 2 lambda plus mu. 2 lambda plus mu, comma. Next is minus lambda plus 2 mu. Next is lambda minus mu. Okay. Dot a vector. What is a vector? A vector is 2 minus 1, 1. This is your a vector given in the question right here. 2 minus 1, 1, right? So 2 comma minus 1 comma 1. Now magnitude of a vector will be 4 plus 1 plus 1. This is going to become 17 root 6 by 2. Yes or no? Okay, let's solve it out. So now 4 lambda plus 2, correct? 4 lambda plus 2 mu. Then minus lambda minus 1. So this is lambda minus, this is plus lambda minus 2 mu and lambda minus mu by root 6 is equals to 17 root 6 by 2. Correct? So this is going to give you 4 lambda plus lambda 5 lambda. 2 mu minus 2 mu. And yes, this is minus mu. That is going to give you what? 17 into 6 by 2. So this is 17. So 5 lambda minus mu is coming out as 7 3s are 21 and 51. Is it correct, guys? Is it correct? Actually, it is 6 lambda, right? Lambda, 6 lambda and minus mu. So this is going to become 6 lambda. Correct. And one more equation I am having from the past, which is 3 lambda plus 8 mu is equals to 0. 3 lambda plus 8 mu is equals to 0. So let us solve it out quickly. So I'll be multiplying 2 and subtracting. So this is gone and this you are going to get minus mu minus 16. So minus 17 mu is equals to 51 minus 3 and lambda is coming out as 8. Okay. Mu is minus 3, lambda is 8 and yes, 8 comma minus 3 is your mu and lambda. Now let's go back. Let's go back and let's talk about this. Okay. So what you're looking for is magnitude of x square. Now put the value of, so what is it? X. Tell me, x is what? So let us calculate x now. So lambda is 8, mu minus 3. Lambda 8, mu minus 3. Let us plug in and calculate this x. So this is 16 minus 3. 16 minus 3 will be 13, comma. This is going to become minus 8 minus 6. So this is minus 8, 9, 10, 11. So now the magnitude of x square will be what? Tell me. 169 plus 196 plus 121, right? This will be your answer. And that is going to give you 486. 486. 486 will be the correct answer of this question. Okay. Yes, yes. I guess I am awaiting the studio. Like one or two parts are missing. I have come back to my hometown for Diwali celebration. Now they are Vedantu is doing a proper studio setup at my home only. So I guess within 1 or 2 days, I'll be having my own studio and I'll be taking a lot of lectures, right? Okay. Now cross product between two vectors. Cross product of two vectors. Okay. So for a cross product is also known as vector product. A cross B is nothing but A B sine theta n cap. This n cap is the vector term over here because A B sine theta all are scalars, right? This n cap is nothing but vector perpendicular to both A and B vector, and specifically unit vector perpendicular to both A and B vector. Okay. So vector is a cross product. You can see this is A, this is B. All right. Okay. So A cross B looks like this. This is your A cross B. Okay. And A cross B. Now a vector which is perpendicular to A and B both is your n cap, which is perpendicular to this, perpendicular to this. So this is your n cap, a unit vector perpendicular to both. Okay. All right. Now let us understand the meaning of cross product. So now A cross B is a vector basically which is very important, which is perpendicular to both A and B. Getting it? Yes. So A cross B, very, very important. Understand. A cross B. So whenever somebody tells you that which is that vector which is perpendicular to both A and B, you'll be like A cross B, dude. A cross B. A cross B is that vector which is perpendicular to both A and B. Correct? Are you getting this point straight? Because this statement alone is very, very important. Okay. Now, second thing, if somebody asks you unit vector perpendicular to A and B both. So first of all, vector perpendicular to A and B both is what? Ma'am, A cross B. What about unit vector? To calculate unit vector, you have to divide it by magnitude of unit vector. And obviously, plus minus sign will be applicable, right? Like this. Okay. All right. Now let us talk about properties of vector product. Unlike dot product, because in dot product A dot B and B dot A both are same. But can you see A cross B and B cross A are same in magnitude. The direction is opposite. So A cross B is minus B cross A. That is the first property. Second property says A cross A is 0. A vector, if you take cross product of that vector, its own vector, it is becoming 0. How come? Because it is A sine 0. Sine 0 degree is what? 0. So that's why 0. So basically here we can say that basically A and A are what? Two parallel vector. So two parallel vector will have cross product 0. Two parallel vector will have cross product 0. Correct? And two perpendicular vector will have dot product 0. So if two vectors are perpendicular, then dot is 0. Two vectors are parallel, then cross is 0. Okay. All right. Clear. Now again, A cross B plus minus the distributive property is applicable. Scalar multiplication, you can attach this scalar with A or B, doesn't matter. If A is parallel to B, then obviously theta is 0 or pi. In both the cases, A cross B is 0, that you already have studied. And if A is perpendicular to B, then what will happen? The answer will be AB sine 90 degree n cap. Sine 90 degree is 1. So can you see that over here? So A cross B will become AB n cap. That's it. AB n cap. Okay. All right. Clear. Now, what happens if A cross B becomes 0? If A cross B becomes 0, then there are three possibilities. Okay, because A cross B is what? AB sine theta n cap, right? So now either A or B is 0 or sine theta 0. Now sine theta 0 means what? Sine theta 0 means what? Both are parallel vectors, right? So three possibilities. Now I cross I vector. I cross I, J cross J, K cross K 0, because a vector, if we take cross with its own product, if we take cross product with its own vector, it will become 0. Okay. This is becoming 0. I cross J, J cross K and K cross I. So now there is a cyclic order. I, J, K. I cross J will become K. K cross I will become J. And I cross J is K. J cross K is I. And K cross I is J. Are you understanding? Yes, the cyclic order. Let me write it in a cycle, then you will understand maybe. See, I, J, K. So if you cross I and J, you will get K. If you cross J and K, J cross K, you will get back to I. Now K cross I will back to get J. This is how your vector product will work. Okay. Okay. All right. Now, if theta is the angle between A and B, then sine theta will be what? Okay, hold on. See, I told you, na, A cross B is what? Tell me. Ma'am, AB sine theta n cap. What will be the magnitude? If I take magnitude both sides, what will happen? Tell me. If I take magnitude both sides, then magnitude of A cross B will be magnitude of A, magnitude of B, and sine theta magnitude will be just sine theta, and magnitude of n cap will be 1. So I can just disappear it. So here if you take the value of, if you calculate the value of sine theta, you will get A cross B magnitude upon AB magnitude. A cross B magnitude upon AB magnitude. Are you getting it? Yes. Okay. All right. Now, if you are having two vectors, A vector and B vector, how to actually calculate cross product? What is the formula for it? Just like we did it for dot product. Now, how to calculate it? So basically, you have to follow that determinant process. A cross B, you have to like proper make a determinant. I, J, K, A1, A2, A3, B1, B2, C3. Right? So I cap will be here, and if you expand along row number 1, you will get A2B3 minus B2A3. Can you see it over here? Yes, ma'am. Now you will have minus J cap. Minus J cap. Minus J cap. Okay, minus J cap. It will be A1B3 minus A3B1, like that. And this is plus K cap, A1B2 minus B1A2. This is how you're going to get. Okay. All right. Clear. Chalo, let's do one question. Are we a question ready? Guys, question ready. A vector is given to you. B vector is also given to you. Find the value of A cross B. Find the value of A cross B. I am here, right here. Find the value of A cross B. Okay. So A cross B, again we have to make the determinant I, J, K, correct? 2, 2 minus 1, 6 minus 3, 2, and that's it, right? So this is going to become what? I cap. Then we are having 2 2s are 4 minus 3, so 1, 1 I cap minus J cap. Then you are having 2 2s are 4 plus 6, 10, okay, plus K cap. You'll be having minus 6 minus 12, okay. So this is I cap minus 10 J cap minus 18 K cap. Can you see that this is actually matching with option B? Right? Yes, Gina, absolutely right. Yes. All right. Now let us move on to the next problem. If the angle between this and this is theta, then they are looking for sine theta. Okay. You know that sine theta is what? Magnitude of A cross B upon magnitude of A, magnitude of B. So magnitude of A will be what? 9 plus 1, 10, 10 plus 4, root 14. This is magnitude of A. Magnitude of B will be 4, 5, 6, root 6. Correct? A cross B magnitude, that for that again, you have to perform A cross B. Okay? This is going to become 1 minus 2, 3, 2, 1, 1. So you are going to get minus 2 minus 3, minus 5 I cap. Then you are having 1 minus 6, so plus 5 J cap. And then 1 plus 4, 5 K cap. So clearly the magnitude of A cross B will be 5 square plus 5 square plus 5 square. So this is going to give you what? 3 root 3 into 5. 5 root 3. This is root 14 and root 6. Correct? So if I cancel out root 3, because see, root 6 now can be written down as what? Root 2 into root 3. Root 3 cancel. So you'll be having what? 5 upon root 2, root 7, root 2. So this is going to give 5 upon 2 into root 7. 5 by root 2, root 7 is sitting inside the option number C. Okay. Give me a big thumbs up if you have understood this. PYQs will do na, we'll do PYQs. There is a session for PYQ. Once we are done with, acha, in session PYQ, see, there is this PYQ. Holika, you said the PYQ is right here, and we'll have one session on PYQs as well. Okay. A vector is this. Can you see? A vector is this, B vector is this, and CB vectors such that A cross C plus B is equals to 0, and A dot C they are giving as 4, and here we have to figure out C square. Okay. All right. Are we ready for this question? See, how will we solve it? We are looking for C square, magnitude of C basically we are looking for. So A cross C, B vector, they are giving it as 0. We don't have C vector with us. Okay. Now, can I shift this B vector on the right hand side? So this is going to become minus B. A cross C is minus B. Now take magnitude on both the sides. The moment you take magnitude on both the sides, or rather square it as well. Square both the sides. Take magnitude and square. So magnitude of A cross C whole square is equals to minus magnitude of B square. Okay. Now A cross C is what? A square C square sine square theta, and this is B square. What exactly do you know? A square do you know? You know A. So A square calculation is not a big deal for you. Magnitude of A clearly is root 2, so this is 2. C square is what you're looking for. C to you're looking for, right? Sine square theta. Hold on. Sine square theta is okay. You don't know sine square theta. Okay, let's keep sine square theta as it is equals to b square. Now b square will be what? Magnitude of b is root 3. This is 3. This is your first equation. Okay. All right. Clear. Now a dot c equals to 4. Let's make use of a dot c equals to 4. This is going to give you AC cos theta equals to 4. Let's square it because you have sine square theta, and if you have cos square theta, obviously it will make more sense. A square c square cos square theta equals to 4. Again, 2c square cos square theta equals to 4. This is this equation. Now, if I add first and second equation, it will make much more sense to both the equations, right? So what you're going to get is 2c square, if you take common, sine square theta plus cos square theta, and this is 3 plus 4, 7. So c square is actually going to give you what? 4, sorry, this is 16, right? The moment you square, you will get 16. 16 plus 3 is 19. So 19 by 2 is your c square. Easy peasy lemon squeezy question. What do you think, guys? What do you think? What do you think? Easy? Yes, Pratharshan? All right, all right. Okay. Now let's talk about Lagrange's identity. Lagrange's identity. Okay, what is Lagrange's identity? Lagrange's identity is so funny. It's just that sine square theta plus cos square theta is equals to 1. Let me show you. Tell me, A dot C is what? Ma'am, A dot C is A dot B. Ma'am, AB cos theta. So A dot B whole square will be A square B square cos square theta. Okay, this is equation number 1. What about A cross B? A cross B, or and that too whole square. So A cross B whole square is magnitude of A cross B only. So this is A square B square sine square theta. Second, now you have to add them. Add it. So A dot B whole square plus A cross B whole square equals to A square B square sine square theta plus A square B square cos square theta. Right? So finally, what you're going to get is A dot B, square of dot product plus square of cross product is going to give you A square B square vibes. A square B square vibes. You know what? I have seen on the Instagram that everybody is like putting a story that, oh, Diwali vibes. Oh, Diwali vibes. Have you also seen? Like people are posting stories. Diwali vibes. They will have a diya, a lamp in their hands. Diwali vibes. Or they'll put some like beautiful things and Diwali vibes. I feel this is so funny. What are Diwali vibes, dude? Diwali is right here. Diwali vibes. What are Diwali vibes? This is Diwali only. Right? So I am also saying A square B square vibes. No, it is A square B square only. What are A square B square vibes? Right? Yes, server. 75% criteria means 11th and 12th both out of 1000 we get. We get 750 plus for JEE means server. No, it is for 12th class. Your result is combined, yeah, in your college. Okay. So this is your Lagrange's identity. Let's do one question on Lagrange's identity as JEE Main 2023. Very easy question. You guys will be doing it right here. Okay, so this question says A and B are two vectors such that magnitude of A is root 14, magnitude of B is root 6. Okay, so A dot B whole square, Lagrange's identity, plus A cross B whole square is equals to A square B square. Correct? A square is what? 14. B square is what? 6. Dot product square we don't know. Okay, and cross product is roots 48 square. So finally, A dot B whole square, directly formula based question. Can you see? 6 fours are 24. 2 carry 6, 7, 8. 84 minus 48. What are you going to get? 36. The final answer is 36. Yes? Okay. Good question. This is like free 4 marks. Free marks. Free marks you will get in this question. Just direct formula based. Free marks. 4 free marks. Do not skip these kind of topics, right? For your JEE examination. Okay, so here we have another question on our screen. Let's see, let's understand. Aryan Kumar. Yes, my name is Namrata Aryan. You are like new student for on this channel, kya? Are you a new student? Aryan Kumar? Chalo. Now A vector is this and B vector is this. C vector is such that which is C dot A cross B plus 25 is equals to 0. C dot A cross B plus 25 is equals to minus 25. Can I write minus 25 over here? Okay. C dot A cross B is minus 25. A cross B. Can I actually calculate A cross B? Yes, ma'am. So let's calculate A cross B right here. A cross B will become what? I, J, K. Right? Then it is having 4, 3 and 0. 3 minus 4 and 5. Now let's calculate A cross B. Okay. So this is 15 I cap minus 20 J cap plus minus 16 minus 9, that is going to become what? Minus 25 K cap. This is your A cross B. Is it fine? 15 minus 20 minus 25, right? Now C vector. C vector is not given in the question. Can you see? C vector. Now I am assuming C vector as X I cap plus Y J cap plus Z K cap. Z K cap. Okay. Let us assume this. So now C dot A cross B will be what? X comma Y comma Z dot 15 comma minus 20 comma minus 25. Right? And this will give you minus 25. So this is 15x minus 20y minus 25z is equals to minus 25. Correct? Yes. 5 3s are 15, 5 4s are 20, 5 5s are 25. 3x and this is again 5. 3x minus 4y 5z equals to minus 5. This is your equation number 1. Equation number 1. What do you think? What do you think? Okay. All right. So I guess this equation we have utilized. Now one more thing they are giving. C dot ijk is 4. So from here, can I just directly write x plus y plus z equals to 4? Basically, we are taking a dot product of xi cap, yj cap, zk cap with I plus j plus k. This is x plus y plus z is 4th second equation in x and y and z. Third is project on a vector is 1. Okay. Third equation, I'll be solving it here. Okay. C dot A upon magnitude of A will give you 1. Okay. So C dot A. C dot A will be what? C dot A will be 4x plus 3y upon magnitude of A will be what? 16 plus 9, 25. 5 equals to 1. So again, this is the third equation. Now, can you see three equations and here? Can you just right away solve this? Three equations, three unknown. We are having three equations, three unknown, right? X plus Y plus Z equals to 4. Second equation is what? 3x minus 4y minus 5z is minus 5. Correct? Minus 5z. Equals to minus 5. And 4x minus, hold on, 4x plus 3y is equals to 5. If you solve these three equations, three unknown, you guys can solve it. Come on. And you will get x equals to 2. X equals to 2. Y equals to. Y equals to, what you're going to get is y equals to, I have calculated for you, minus 1. And z equals to 3. Yes, this is what your xyz is coming out. That means your C vector, C vector is 2, minus 1, 3. What are they asking? 2 minus 1, 3. So, projection of C on B. Okay. Projection of C vector on B vector. Finally, we are here to calculate. So, C vector is 2, minus 1, 3. Okay, projection of C on B. Hold on. Projection of different color. Projection of C on B will be 2, minus 1, 3, and your B vector is actually what? 3 minus 4, 5. Of 9 plus 16 plus 25. If you solve it, what you're going to get is 6 plus 4 plus 15 upon square root of 25 or 25, 50. So what you're going to get is 15 plus 10, 25 by root 50. Or you can just say 5 by root 2. 5 by root 2 is what you're going to get. Yes? Am I fast? Okay, Gina. Just, no, actually, see, this equation solving I have not done right here. This I have done it for you already. I didn't want to waste time in equation solving. So just I have given you x, y, z values. Once you are done with that, your C vector is what? X, y, z. And here is, you have C vector, you have B vector. Just do the calculation and you're done. Okay. Better, Gina? Okay. Now let us talk about area of a parallelogram. Let us talk about area of a parallelogram quickly. Suppose a parallelogram is given to you. This is your A vector. This is your B vector. And this is your A plus B vector. Correct? By triangle law. And the other diagonal which you are seeing will be what? Tell me if this is your B. Right? If this is your other diagonal, can you apply loop law for me? Basically A, then plus diagonal and minus B equals to 0. So B minus A, this is B minus A. The other diagonal is B minus A, right? Okay, so this is your vector. Now the geometrical interpretation, let me just show you. Okay, so this is your parallelogram. Again, A vector, B vector. This is your theta, correct? What about this perpendicular? Can anybody talk about this perpendicular and or this perpendicular? This thing, okay, this perpendicular. So can you remember the vertical component in physics? If this thing is your A, understand. If this thing is B, then this will be what? B sine theta, vertical component. This is B cos theta, so this is B sine theta. Area of parallelogram, you know. Area of parallelogram in mathematics, you know the formula. Base into height. Base into height. Now in this case, base is this length, right? A. Height is this b sine theta. A into b sine theta. So this is going to become AB sine theta, right? AB sine theta. AB sine theta is A cross B. That means if at all in vector form, you have to calculate area of parallelogram, just figure out A cross B magnitude and you are done, and you will see direct questions are asked in this from this particular thing over here. So can you see that a question was asked in JEE in 2021 from this formula, which is area of parallelogram. Okay. All right. Alpha is, A vector is given as this, B vector is given as this. Area of parallelogram whose adjacent sides are A and B is 8 root 3. Then they are talking about A dot B. Okay. All right. So now what we will do is A cross B magnitude. They are already giving A cross B magnitude is what? 8 root 3. So let us calculate A cross B. Let us calculate A cross B. I, J, K. Right? 1 alpha 3. 3 minus alpha 1. So this is going to give you alpha plus 3 alpha. So 4 alpha I cap. Okay, ma'am. Then we are having 1 minus 9. So 1 minus 9. So plus 8 J cap. And plus here minus alpha minus 3 alpha will become minus 4 alpha K cap, my dear friends. Right? Yes, Gina? Okay, we'll do it one more time. Focus on this question first. We'll go back. Basically, 4 alpha, comma 8, comma minus 4 alpha is your A cross B. Magnitude of A cross B, can anybody tell me? Square root of 16 alpha square plus 64 plus again 16 alpha square. Can I take 16 out? So it will become 4 alpha square plus 4 plus alpha square. 4 times 2 alpha square plus 4 will become 8 root 3. 4 ones are 4, 4 twos are this. Square if you do it now. 2 alpha square plus 4 equals to 12. 2 alpha square is 12 minus 4 is what? 8. So alpha square is your 4 basically. Alpha square is coming out as 4. Now they are talking about A dot B. Hold on. A dot B, tell me. A dot B is, ma'am, 3 minus alpha square plus 3. So basically 6 minus alpha square is what they are looking for. 6 minus 4 is what they are looking for. 2. 2 is the correct answer. So 2 is absolutely right. Yes, Trisha. Why this mode of teaching? You guys are not liking my like iPad teaching or what? Huh? But it's not that I'm doing it deliberately. I am awaiting my studio in a week. Within a week, I'll be having my own studio setup, like digital board setup. Then I'll be taking classes from that only. Okay, clear? This question is cool. Any doubts in this? Okay. Now this is a homework question for you guys. Homework question. Okay. Before homework question, I want to teach you, Gina. Yes, board teaching is another level. I know. I also like board teaching, but yeah, I also enjoy this. This is actually more calmer space. You can ask doubts. I can look at the doubts. This is a slow motion kind of lectures, and I actually enjoy both style of teaching. Okay, so Gina was asking very important question, by the way. Understand this. If you are having a parallelogram, you must be aware about this thing. This is your A vector. This is your B vector. Okay. Tell me, loop law if I apply. So this is your D1. Diagonal 1. Right. And this is your diagonal 2. Can I just do that? Diagonal 2. Okay. And again, this is your A vector. So this is your B vector again. Same direction, na? This is also B. This is also B. Yes, Gina, clear? A, B, C, D, parallelogram. Now, in this parallelogram, tell me, area of this parallelogram, who will tell me? Area of parallelogram will be, ma'am, magnitude of A cross B. Okay, all right. Now, suppose if the diagonals are given and not the adjacent sides, then what is the formula? Okay, if the diagonals are given and not the formula, so area of parallelogram is half D1 cross D2. Okay, half D1 cross D2 if the diagonals are given. Okay, now Gina was asking, how did you get the diagonals? By loop law. Okay, can anybody tell me how to get D1? Let's apply loop law. I will start from here, Gina. I am going with AB vector. So A vector. Then I am going with B vector. So plus B vector. And then I am going, this is your D1 by the way. This is your D1. Okay, this is not D2. D2 I will remove. I'm only talking about D1. Yeah. Then you are going against D1. I'll start from the beginning. You are starting from here A vector plus B vector minus D vector. Minus because so A plus B minus D will give you 0. So your D1 vector, diagonal number 1 is what? A plus B. Are you getting it? Yes, or B plus A. Now to get D2 diagonal, the second diagonal, this is your second diagonal. I will be applying loop law. This is your second diagonal. This is your D2. I'll be applying loop law over here. I'll be like going like this. So again, A vector plus B vector. Okay, so D2 के लिए A vector plus D2 vector minus B vector is 0. So D2 will be what? B minus A is your D2. And B plus A is your D1. This and this. Got it, Gina? Okay. Now, just tell me that A cross B. Now, see, D1 is B plus A and D2 is B minus A, correct? Just tell me, if I add these two, D1 plus D2 I will be getting, which is what? 2B vector. And D1 minus D2 I will get, which is what? 2A vector. Okay, this 2, if I just keep it here. So basically this A cross B will become D1 cross D1 plus D2 by 2 and D1 minus D2 by 2, cross product between them. Right? Okay. Now D1 cross D1 is 0. D1 cross D2 will be, okay, so minus D1 cross D2 and D2 cross D1 plus D2 cross D1 and 0 by 4 magnitude. Okay. So this is actually going to become 2 D1 cross D2 by 4 and this is half D1 cross D2. Okay, so you have to remember two formulas. These are the two formulas that you have to remember. Area of parallelogram when sides are here, A cross B. When diagonals are given, half D1 cross D2. Will you be able to remember it? If yes, then this is the homework question which was asked in JEE in 2024. That this is your A, this is your C. So basically they are giving you A and C. A is given, C is given. Right? So you can write one diagonal, right? If the diagonal BD, now BD they are giving already. So BD they are giving, right? AC, you can figure out AC, that will be your D1. And BD they are giving, that will be your D2. Now half D1 cross D2 will give you final result. Yes, Gina? Will you be able to do it? Comment the answer below. It was asked in JEE in 2024. I have pasted the answer also here. That's how you have to do it. Okay. Now area of a triangle, just like area of parallelogram, we have to understand area of a triangle. Okay, suppose A, B, C. Three vertex are given to you. This is your A vector, this is your B vector, this is your C vector. Okay, so the area of vector will be half AB cross AC. Half AB cross AC. Half AB cross AC. Half AB cross AC. So AB is your B minus A vector. B minus A cross AC is C minus A. Okay. AC is C minus A. If you solve it, you will get half. B cross C plus B cross A. Sorry. Minus B cross A, I will write it as A cross B plus. Minus A cross C, I will write as C cross A, and A cross A, I will be writing at 0. So if you solve it, you will get this. Yes. Okay. All right. Now, only two topics are remaining. Two topics and we are done. Like we will be done in almost 10 minutes. So here is this thing. So these are very popular type of a question. When an unknown vector is missing, very important. The type, the category is very missing. So simultaneous, basically solving simultaneous vector equations. Okay. And there to solve these kind of equations, to solve these kind of questions, we have almost similar method. Okay. So they will give you A vector, they will give you B vector, and they will give you one equation with unknown vector. That will be very difficult to solve. Okay. If you don't know the trick. And now you have to figure out R vector, and eventually, and one more like information they are giving about this. And eventually you have to figure out that unknown vector. Then they can ask you about anything. They calculate dot product between unknown vector and something like that. Okay. Eventually R vector is the key. You get R vector, then they will ask you anything. You will calculate how to get this R vector. And you have this very equation. You can see this equation and this information with two different informations. Okay. The first thing is R cross A equals to R cross B. This is what is given to you. How to tackle this? So you have to shift this on the left hand side and get R out. R you have to get out. R cross A minus R cross B equals to 0. And now R you can take common, R cross A minus B. Now who can tell me? Who out of all of you can tell me that what happens when cross product is 0? Cross product, very important. Cross product is 0. Means what? That these two vectors are parallel vectors. Very few people will be able to write it down that if cross product is 0, then they are parallel vectors, and if they are parallel, R vector is equals to lambda times A minus B vector. Just tell me. Just tell me. This student who will be able to write this will be able to crack this question. Now this question is done. Okay. So cross product means parallel. But parallel means if two vectors are parallel, remember A and B are parallel. A is equals to lambda B. So if R and A and B, A minus B, so R equals to lambda times A minus B. So R will be what? Lambda times A minus B. So minus 5 and minus 3 minus 1. So minus 4. 4 minus minus 6, 10. This is your R vector. And now one more piece of information is given to you. This information, you just apply it. This is minus 5 lambda, comma minus 4 lambda, comma 10 lambda. Dot, take dot with 1, comma 2, comma 1. It will give you minus 3. Let's just solve it out over here. So this is minus 5 lambda, minus 8 lambda, and 10 lambda equals to minus 3. So 10 minus 8, 2. 2 minus 5 is, 2 minus 5 is what? Minus 3 lambda equals to minus 3. Lambda is coming out as 1, my dear friends. Lambda is 1. Your R is sorted. That means your R vector directly is what? Minus 5, minus 4, minus 10. Now you ask me anything, I'll be able to write, right? So this thing will be what? Tell me. So you have to take dot with 2, comma 1, right? Let's take dot. You will get what? Minus 10 plus 12 and minus 10. So this is going to become what? Tell me. Minus 5, minus 4 and plus 10, right? So this is plus 10. So this is 12 only. 12, 12, 12. 12, 12, 12. Option A. Okay. Hi Himanshi. I guess one student was writing, ma'am, how are you getting that coordinates? How are you getting coordinates? These are not coordinates actually. So this is my way of writing. I hope you guys are understanding that rather than writing I cap plus 2j cap plus k cap, I write 1, 2, 1. It is not correct way of writing. It's just that I don't want to do that labor I cap, j cap, k cap. Okay, that's why I do that. It will save time basically. Okay, save time, save more than time. It saves mental effort because you do draw that I cap, j cap. You're only working on numbers. Now keep that in mind. Okay, so this is how I do it. Yes, Gina, getting it? I will highly recommend do all the questions at your own pace and you will be fine. Now, the last topic of the day. Yes, last topic is linearly dependent and independent vectors for two non-zero vectors. It's really, Magnus is laughing. It's really irritating. Yes, I then cap. I like remove it. Go to hell. Okay, only deal with numbers. And I to feel that it helps me a lot. It helps me mental effort because your whole focus is not on logic. Caps everywhere. You're just doing this cap thing everywhere. Okay. Now this is again very important. Linearly dependent and independent. See, this topic might confuse a lot. You go and watch any other video lecture, you'll be like, ma'am, we are not understanding linearly dependent and independent. But this time you'll be like, oh my God, now I've understood. Okay. So linearly dependent, talk about what happens when two vectors are in picture, what happens when three vectors are in picture, okay, like that. Okay, so for two vectors, if two vectors you say that they are linearly independent, that means they are parallel. That's the another word for parallel vectors. So if two vectors are parallel, they will be linearly dependent. So basically linearly dependent means you are able to write A is equals to lambda B. This is a dependency. Okay, and if A is not, A is equals to lambda B means lambda will become 0. This lambda will show you. Right? Okay. If there are three vectors, right? If there are three vectors, if three vectors A, comma B, comma C, if three vectors are, let's say, linearly dependent, then what do they mean? Linearly dependent. Then these three vector means A and B and C are coplanar. Condition of coplanarity. What does that mean? If basically three vectors are coplanar, remember, the theorem and plane come into the picture. Three, basically what you are saying is C vector is lying in plane of A and B. So can XA plus YB. So basically, if three vectors are linearly dependent, they are coplanar. So the third vector is XA plus YB. Theorem in plane I am writing. Okay. And if they are linearly independent, do you mean that A, B and C are non-coplanar? Yes. Non-coplanar. Now, what about four vectors? Gradually, we are increasing 2 vector, 3 vector, 4 vector. Now, 4 or more vector will always form linearly dependent system. right? So four or more, like five vectors, definitely they will be linearly dependent. It can't happen that they are not linearly dependent. Okay, so this is the last thing that we had to study now, and I'll be taking your leave, guys. We are done with vectors chapter. The next session which you have to look forward is 3D geometry, and one more session, two more sessions that you should look forward to is vector and 3D geometry PYQs. How can you forget? Vector and 3D geometry PYQs, right? So we'll be solving it, and post that, I guess, definite integration, Sanjay, you are asking. So post that, definite integration will be there, area will be there, differential equation will be there, statistics will be there, probability will be there. I guess by the mid-November, we'll be able to do all the chapters. And once we are done with that, we'll start with a new problem solving series, revision series. A lot more is there on the plate. Do not worry. Yes, Sadia, you find it easy. Great. Yes, Magnus, 2026 aspirant. What a good job. Good job, Magnus. You're attending lecture end to end and that to vectors. Good job. Okay. So I believe that now we are done. I should take your leave. This is me, Namrata ma'am, signing off. I'll see you all in next video, upcoming video.